Today, we will explore the insights of a hydraulic jack and understand its working principles. The hydraulic jack uses two advantages to multiply the applied forces. One is the principle of Pascal's law, and the other is the principle of levers. The hydraulic jack has a smaller piston, which is connected to a larger piston using a hollow tube. Let's understand how a hydraulic jack uses this setup to multiply the applied force. Here is a simple setup to demonstrate the basic principle. A smaller cylinder with cross-sectional area of A1 is connected to a larger cylinder with cross-sectional area of A2 by using a hollow tube. When a force F1 is applied on the smaller piston, the pressure of F1 by A1 is developed inside the smaller cylinder. This develops a pressure of F2 by A2 on the larger cylinder. Since the system is confined, Pascal's law is valid, so we can say that pressure at smaller cylinder is equal to the pressure at larger cylinder. This clearly tells us that force at larger cylinder is pressure at smaller cylinder multiplied by area of larger cylinder. Due to this reason, a large amount of force is developed in the larger piston when a small force is applied on the smaller piston. Now let's see how the hydraulic jack uses the principle of levers. Levers can be used to exert a large force over a small distance at one end by exerting only a small force over a greater distance at the other. If we apply a small force at the point A of the lever and displace it through a long distance, then the point B of the lever moves to a short distance but with greater force. This same principle is used in the hydraulic jack to multiply force. Now let's see some practical circuits showing the working of an actual hydraulic jack. It consists of a reservoir to store hydraulic fluid. A hollow tube connects the reservoir to the smaller cylinder. Another hollow tube connects the smaller cylinder with the larger cylinder. Now the animation shows the working of the hydraulic jack.